Buddy, welcome back. Today we are working on our QR code scanner, and what we want to get to today is try to figure out how to work with a QR code that's not perfectly axis aligned, right? So we've been working with, like, if I type into like DuckDuckGo and I say like hello world QR code, or maybe I type in QR code hello world, right? Like, it gives us an image, and the idea is that you like take this image and you slap it on a piece of paper and you put it out in the world and you scan it with the cameras, right? We've been kind of working with that version of this, right? And so we've made a bunch of assumptions about our QR code being perfectly axis aligned. The fact, I guess it is just like perfect axis alignment. We've also made some assumptions about like the fact that we are expecting perfect lights and perfect darks, but we've kind of come up with some strategies in the past few streams to deal with that problem at least. So what we have here is the plan of action for decoding this guy is we try to figure out where the finders are. From the finders, we walk this. We walk this row here and this column here, and these guys are like special columns and rows in the QR code where they have like alternating white, dark, white, dark, white, dark, white, dark, and they're guaranteed to have that kind of. And so from there, you can kind of figure out what the expected module size of your QR code is, where module is like one block. Then once you have that, and you have the corners of your finder, what we're doing right now is we go, okay, so we know that our finder goes like boom, 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 right? This makes a box. We know the size of the module, so we start in the bottom right. We just kind of go like beep, 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 beep. We walk this like special pattern. We won't go into that right now, but there's like a pattern that we walk given the module size. And so we're trying to get to the same point, but with a rotated QR code. So we put when we were playing with perspective yesterday, so this is a screenshot of a QR code on a plane in Blender, and then in Blender we were kind of like tilting the camera and seeing like how it worked with different perspectives and stuff. But this one's like pretty head on. Like, this is essentially just a normal rotation. And what we have here is we have made sure that our like boxes now are correctly identifying one, the orientation of the finders, but two, it's also identifying which one is which is important because our QR code might be like, if it's 90 degrees rotated, we have to make sure that we're like, we know which direction is which. And so this one's in red, showing that it's to the right, and this one's in blue, showing it's to the bottom, this one's yellow, showing it's the top left. And then we draw our little like blue and red axes here to say, this is like the direction that we think that the QR code is. I'm pretty sure that with any amount of like real perspective, this will get fucked. But for now, let's just start with rotation, and then we can upgrade to perspective later. Maybe we won't ever upgrade. Who knows? And then we get stuck because we try to do this like horizontal timing walk, and we go like, yeah, that doesn't really match jack shit. That's not doing what we expect at all. So I think what we want to do is we want to figure out how to adjust our iteration so that we're not just walking the x-axis of the image, but we're walking the x-axis of the QR code. And as part of that, what we do to check these timings is we kind of guess what we think the size of the module should be based off of the width and height of our finder. And then we go, okay, so as we walk this, can we like check like the average brightness of this module? The idea being that if there's like a little bit of sensor noise or something, or like just a few pixels that are out of place, that won't just like totally like tank our results. So if we want to apply that same pattern here, we need to support averaging the brightness of a non-axis aligned box. And so I think that's the first thing we have to do. Then if we manage to get that done, then we can try to figure out how to walk this line and see if we get the right values. And if we get through all of that, then maybe we can do the like proper zigzag. But who knows how far we'll get today? Who knows? Who knows? Okay. So I think there's a couple approaches here. I think. Oh my god, I forgot to fucking fix this. Hold on. This is so fucking annoying. Sometimes, like my paint application, if I like accidentally drag this out, this thing, it becomes like a separate window and I can't put it back in. And the only way I know how to put it back in is to like delete the config file. So, one sec. It's just really fucking annoying. It's under config, color paint RC, or maybe it's local share dot color. Yeah, I think that's probably gonna do it. We'll see. Please. Thank God. Okay. Yeah, if you ever just never accidentally click this, or you're fucked, is my current thought. But maybe there's probably some button in the UI somewhere to fix it, but I just don't know what it is. Okay, sorry. What were we saying? I think there's a couple of different approaches here. Right, so we have some box rotated by some angle. That's how we're representing it right now. And so we're kind of representing it as, well, right now we're representing it as these 4 positions where we have like y, x, x, y, and then we just tacked on a rotation last stream. So 5 values. Really, probably what we should be doing is we should be tracking the center as well as its width and height, because storing top, left, right, and bottom doesn't really necessarily make as much sense in this scenario, because in this rotated version, you might think that this is left, but that's not true. It's like this. Like, what does this even mean? It's like center minus width over 2 is what our left value is. So we'll have to fix that eventually. But for now, we can maybe leave the representation as is. We can pretend that we're storing it as center, width, height, because this can be transformed into width, height pretty easily, and center, like from these 4 points. So it's fine. It's fine. Okay, so what was I actually trying to say? There's a couple approaches here. One is that we could walk this whole box, this whole dotted line box, and we could hit test every pixel in here, right? So we go like, is this pixel in the box? No. Okay, what about this one? No. What about this one? No. What about this one? No. What about this one? Yes, that one's in the box. So we'll take that pixel value and keep going, and do it again here. Boom, 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 boom. And I think that's probably easier to implement. And I think that if I were to be doing this on the GPU, I think that's probably the correct approach, right? Like you can massively parallelize per pixel hit tests, and then you're fine. I think that's usually how you do GPU stuff. It's like you would kind of over allocate and then per pixel make a decision on what you're going to do. But if we're doing it on the CPU, it might make more sense to kind of try to split this into its 4 lines. So maybe we do something like we have, our box, and we have like this line is this is like, you have your like high school y equals mx plus b, right? And so you could do something like, well, we could like find these 4 corners, and we could do something like, well, we know the slope of this line and we know the start of this point, and so every y value you walk down this way, you could find an approximate, you could like find the left edge of this by following the slope of the line, right? You have like, you can basically split your rotated rectangle into 4 triangles like this, I think. Maybe you consider them 2 triangles. Maybe you only need no, hold on. Let's draw it in a way where it doesn't look like the corners line up as well. 1. So you'd have like three segments, right? One where you're kind of like expanding this way, one where you're kind of just walking diagonally, and one where you're contracting, which I think is like something like 2 slopes and a couple x positions, maybe. Not really sure. And this one's like better. This approach works better for, I think. Oh, I could be wrong, right? I think if I had to guess, I would guess that this is better for on CPU than this approach, because I would guess that only looking at the pixels that are relevant to you is better. Hand wavy. I could also see maybe there's an argument that this approach on the top, like this approach over here, maybe that's more SIMD optimizable, right? So maybe like if the gaps are not that big, the fact that you have a constant width might make it so that SIMD operations are easy, like what do you call it? Auto vectorization, right? So you write like a normal loop, and then your compiler goes, oh, I see that loop, but I've noticed that you're always doing things 8 times with, like, you're always working with like, 64 U8s in a loop. So I'm going to like unroll that, pack them into 64-bit registers, and then do a bunch of things at once. Sometimes that can happen, and I could see an argument that this will happen that'll happen here easier. Because I know in the past I've struggled with if your loop, if the compiler can't figure out the width of your loop, like if it doesn't know that you're going to be doing 8 iterations at a time, sometimes you have to like split the loops manually to force it to figure it out. So I could see an argument that maybe this top left version is better. But you know, I think that this bottom right one I have like higher confidence in, and I kind of want to try it. So, I think, well, yeah, I like the idea of only looking at each pixel one time. I like that idea, right? In this, like, if we imagine that we start sliding this window, like, these errors will start to like stack up. Yeah, I don't know. Where can I find material to read about this and figure out how it works for myself? Okay, so there's a GitHub repo for this. There's the Wikipedia if you want to like look at the code I've written. Let's just be clear that what I'm writing is garbage, right? Like I'm just like guessing and doing the first thing that I think of all the time, right? So like you could look at that, but I don't know if you'd want to. There's the Wikipedia article on QR codes has a bunch of information in there that's like an okay jumping point. I found this like QR code step by step. This page is really good. I'll post it in chat. And it has links down at the bottom. And this Thonky one is pretty thorough as well. So there's also like the QR code specification, but you have to spend like 250 USD to get it. Or you can look up the ISO code and maybe type the word PDF into Google. Maybe they'll give you something. Who knows? I wouldn't know. Maybe it's on there. Maybe it's not. Who knows? I would never suggest... you shouldn't type PDF into Google because then you might accidentally steal something, you know? You wouldn't want to do that. Okay. Reminds me of rasterization. I think it's the same thing. I think that like this, like walking each pixel and looking at it and walking each pixel and drawing something in is like essentially the same. So I think you're right. I think this is just rasterization. Okay. Zig has good explicit SIMD support. Yeah, that's just like a lot of work though. I prefer I think that probably it's not worth it. Probably. Okay. So how do we want to do this? Probably what makes sense is some way of like visualizing if we get this right or not. So maybe we do something simple. Like I think somewhere in here, I have a BMP writer already. So we could do something like we could create an image, stick a rotated rectangle in it somewhere, or sorry, yeah, rotated rectangle. We could like define a rotated rectangle and then try to draw it in this image and render out a BMP and see what fucking happens. That seems reasonable to me. And then probably just banging out a new application to do that is probably the fastest way to test that. Probably. Yeah, let's do that. Okay. So, or we could just hijack something that already exists. Maybe we'll do this. We'll say rotated rect test. And in here, we will delete pretty much all of this. And he is going to do something. He's going to get some sort of rectangle. So this is going to come, I think that we have like libqr types 2D rect. And I guess we will define his like coordinates. So we'll say that his left edge is at like, I don't know, 30. His right edge is at 50. And top and bottom are going to be maybe 30 and 50 again. And then maybe we make our image like 100 by 100. Okay. So maybe we say, hey, let's make a new image. So this is like image. I think that we can do from Luma. Right. So here we pass in. Well, what's our bump writer? Maybe we don't even have to. We might not need this image abstraction. Our bump writer, he says, hey, could I write into this output this data, which is RGBAs, and my data has this width, and you can figure out the height from that. So I guess we don't even need this image. We can get away with just const bump writer is equal to import bump writer zig. And I guess let's just start by making like 100 by 100 image that has color in it so that we can figure out if it fucking works. So let's do bump writer right bump. We need a writer, so we'll open some file. Create file. I think when you want to do working directory relative, you do give me the current working directory and then create a file, which is kind of a misnomer. Create file is create or open file in this language. And so we'll just say test bump for now. Who fucking cares? And we don't really care what it tries to do. Just give me a fucking file, please. I think I have to write try, and then we say const f is equal to this, and then we get the writer from it. And we need some data. So const data is equal to, I guess, if we want a 100 by 100 image, we're going to have to make bump pixels. So we'll say bump writer bmp pixel, and we want, you know, width times height of them. So let's const width is equal to 100, and height is equal to 100. And I think that you actually, let's actually do this. We'll say this is equal to one of these guys, and then we initialize him with some shit. So b is equal to, let's just make him blue or something. I don't know. Green and red we'll just set to 0 or something, just so that we have like an unexpected color. And then we say, hey, could we like make width times height of these guys? I think that's right. So this is like saying like, hey, Zig, could you like splat this shit out? So I give you an array of 1 and I double star this, and you just like duplicate this n times. And so we take our writer and we shove our data in and we shove our width in. And I think that should do it. Initializing an array. What's this complaining about? With struct syntax. Oh, I need to say, hey, I want to derive this thing inside. Okay, cool. And then let's add this to our build system. For now, this isn't where it's going to live forever, but it is where it's going to live right now because the bump writer is like just part of some application, not part of some library. So we can go into build zig, and wherever we set up our binarization thing, we'll just add a new executable where we do probably all the same shit. I'm not really going to worry too much about it. So this is a bump test. What did we call it? We called it like rotated rect test. That's what it was. Test. This is rotated rect test. And then everywhere we see exe, this is rotated rect test, rotated rect test, rotated test. Okay. Boom. So I think now if I build this, I should get a binary associated with that file we just added. Maybe. That'd be pleasantly surprising if this worked. Oops, wrong source path. Oops. Okay, there we go. Now it doesn't compile, like I would have expected. This is more like it. Alright, so I think it's complaining because here I need to write an ampersand. And then, am I right using the right version of language server? Yeah, I am. Okay, cool. Cool. Okay. So we should see a blue 100 by 100 image here, which this is blue, which is good, and it is 100 by 100, so we're chilling. Okay. which means that now we can start trying to do the more interesting stuff, which is something like, so this right bump will go at the end no matter what. And let's say that we have some rect. Is a libqr types 2D rect using backed by floats. And we already did this. We said we were going to do like left is equal to 30, right is equal to 50, and then bottom and top. Something like this. There we go. And then let's just start with an unrotated one, and then we'll adjust later. So let's do something like, we'll make like a pixel iterator. In this language, you write const pixel iterator, because pixel iterator is a variable that happens to be a type. And we say, hey, this is a struct, and that struct is going to do something. He's going to, like, maybe, for now, what are we going to take in? We're going to take in, like, the rect that we are working with. So let's maybe say that we are going to have, like, a rect type, which is the float version of this guy, which I think every single rect in my entire project is the float version of this guy. I think temporarily we were working with integer coordinates at some point, but then I scrapped that, so I should just undo that at some point. But for now, we live. Maybe he doesn't even store the whole thing. Maybe he just stores a pointer to one that he is using. And he's also going to take in his current position, or maybe like how many steps that we've taken. Yeah. So we initialize this guy with some rect, and we return a pixel iterator, and we just return, you know, I equals 0 and rect equals rect. I'm new to Zig, but I'm in love with it after a 30-year career of Ruby, Rails, Java, J2E, Struts, ASP Classic, etc., etc. I can't get enough Zig. It's so funny. Like, I've never touched any of those. Just like by chance, I happen to be, yeah, C++ only. How, like, I guess 30 years of Java is like possible at this point, huh? Java age. How do I calculate someone's age in Java? Shut the fuck up. This isn't what I want. I want Java's Wikipedia page. And it's gonna fucking tell me about coffee. Fuck. Java programming language. One's like, yeah, 1995. I guess that's crazy. We are at like almost 30 fucking years. That's crazy. I just assumed that programming 30 years ago was just C. That's just what I assumed, but I guess I'm wrong. Please don't take this the wrong way, but the doom screen is very distracting. Yeah, I think it's like a generational thing. I think that some people will love it, some people will hate it. And I'm just going to leave it there because, you know, coding's fucking boring, you know? It's the way it is. And so giving, like, my stupid fucking brain, when I'm watching these VODs back, I'm like, oh, something to look at, my brain. Ooh, monkey brain. We move. Yeah, this guy's saying the doom screen helps him lock in. So, totally depends on the person, I think. Unfortunately, it's just one of those things where some people love it, some people hate it. Probably nobody loves it. Some people will hate it, and some people will be okay with it. Okay, what we're doing, we were trying to write a pixel iterator here. So, we want to go, we have, like, taken our self by pointer. Yeah, and we will return probably, like, an XY position. I think that makes sense. We could just output the pixel, like the pixel directly. But right now it's not tied to our like image abstraction at all. So I think probably just outputting a position will make more sense here. So we'll do something like X is a U size and Y is a U size. And we'll go output here. And we will, this is where the work happens. So for now, since we're assuming we're axis aligned, we can just do rect left. Const width is equal to the right, or I guess we just have rect width here. And we do what? I% width is the y. No, that's the x. And const y is I over width. Yeah. And then we have to actually add this to self-rect top and this to self-rect left. Okay. Okay. There's a good chance it'll crash eventually, the animation. It does crash sometimes. I don't really understand why, because you would think that if it worked the first 25 times, it would work the next 25 times, because it's just like the same script running in Godot all the time, but I guess maybe there's like a leak somewhere and eventually I run out of memory. Maybe. Okay, and then we return something. What is this thing? An output. So we just return X and Y. Yeah. We need to write self on this. And then we also have to say, hey, sometimes we're not going to get anything. Wouldn't other things be effective if it was a leak? If it doesn't leak to the point where it's like yeah, I guess, because like usually my computer just grinds to a fucking halt when I run out of memory. So unless it's trying to do one fucking massive allocation, then maybe not. Sometimes I do see things just crash because they try to like allocate like 20 gigs and then just give up before they hit any like negative repercussions. We have to increment I, and then we also have to say if self I is equal to or greater than or equal to what? It's like width times height, right? Width times height. We return null. Side note, recently I was a little concerned about like this like iterator mechanism and if it was the same as doing a for loop. So I did just do this test where I did like a string iteration using both like this style iterator and like a regular for loop and checked on Godbolt, and it was like, it's pretty cool that it turned into like the exact same assembly, but only if I did this defer self.i down here. If I do this up here, all of a sudden then this one gets shittier. But if I do the defer this down here, then it's like you do like the condition check in the for loop and then like the increment only if the condition check passes, etc, etc, etc. Kind of neat. Okay. Yeah, that should work. So we should be able to say now, we have some iterator with that we initialize with our rectangle, and we say while it next, we get some pics, and then we do what? We say our data at y times. Interesting about the defer placement of the better code gen. I think it makes sense, right? Because if you put it up here, you can't like exit out of the loop early, right? Like even when you return null, every time you call this next function, you have to do the increment. But if you do it down here, then like the compiler is smart enough to figure out that like the loop is over and don't like fucking worry about it anymore. I think it makes sense. So we have y times width plus x. And hopefully if we just do this is equal to, like, let's just make this green or something. So something like this. Hopefully we see, hopefully if we do this, then we see that we have like a green box at the location that we wrote. Somebody's mad about, oh, fuck me. Is this a problem? The fact that these are floats? I think not. I think we just do int from float. Int from float must have a known type, so it's as usize like this. And zig build, and then we run it. Boom. Of course. Of course, of course, of course. This, we need to do the int cast here. There we go. So you go int from float. And we could round, but I don't give a fuck. A little bit of off by 1 on the edge isn't the end of the world. I'm not going to worry about it at this point. Maybe I will later, but not right now. Here we need this guy as usize as well. As usize int from float. As usize int from float. And this guy needs a capital F. Boom. And hopefully we're chilling? No? It's hard life out here. Hard life. So here I need to say, hey, I want to iterate this guy as... No, I don't need to say that. I lied. Here I need to write that this is mutable. No, not that one. This one. Yeah. And explicit moment. I like it. That's really funny. Okay, so if we refresh this, green square, and I think that's in the right spot. There's no like hover thing that tells me, but that looks about 30 to 50. This is centered. This is on the left. I think we're chilling. Okay, so now we can start getting crazy with it and start trying to figure out. Well, let's checkpoint because I break shit all the time. We'll call this checkpoint axis aligned pixel iterator, and I'll fix it later. We'll clean up our commits before, before they go in for real, but for now, I just write whatever the fuck I feel like. And in here, so what are we gonna do? We're gonna take our 4 corners, and we just sort them by height. So I guess we have to first find our 4 corners, right? That's the first step. So what are those? Let's see. Function. Find rect corners. This will probably end up being part of the rect API, maybe. I don't know. We'll see. And this will take in a rect. And he will return 4 points. And I don't think we have a point thing yet. We can make one. It's probably about time. It's probably about time. So we'll just do const point is equal to a struct. I like that I copy pasted something and I ended up deleting every single part of it. But in my head, it still feels faster to start with a copy paste, which is really fucking stupid. Here we're gonna have f32, y f32, and then this guy just say const point is equal to libqr types 2d point. Boom. I guess there was never any point in me calling this types 2D. Surely I'm never going to end up with a 3D type in this project, right? But whatever, it's fine. So we need 4 points. And so what do? We look at like the rect. So we have like the bottom right point is going to be he's going to have like he's going to be some point. And his x value is going to be the right side of the rectangle, and the y value is going to be the bottom value. And if we are going to apply a rotation to this, it's what? We have like, we are rotating around the center of our box. So we have like bottom right here, and let's like draw it at an angle. I guess is probably makes more sense. Boom, 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 boom. So the center is here. It's getting rotated like this, based off of this angle. I guess it's like we have what? Where is the rotation angle in this? Can I draw less of an incline so that I can think about it a little easier? So we're trying to find, if we rotate around, oh, it's easier to draw, hold on. We'll draw it with the coordinate system fixed like this. This will be easier to think about, I think. Maybe. Who fucking knows? And we'll just draw like maybe a box like this. There we go. Where's my eraser? Is it? Yeah. There it is, baby. Okay, so if we're trying to find this location, the hypotenuse of this triangle is the distance of the corner to the center. And then the x position is the amount that we rotated, cosine, related to this guy, and this is sine. Yeah. So x is I guess we need const br dist from center. This is going to be like the rect cx minus we'll say brx dist is the cx from center is rect right minus this. Then we do the y distance as well. So this is bottom and y. And then the length of this guy is this squared plus this squared. And then we square root this whole thing. So br dist is equal to this. And then we have x is stud math cosine the rect rotation times br dist. I guess this br distance should be the same for every corner. So we can just say corner distance. And we can just say, note, assuming symmetrical, since it is a rectangle, the center is equidistant from all corners. If this was like an arbitrary quad, this wouldn't be true anymore. But in this case, I think it's fine. And then here we can say corner distance. Okay. And then this is stud math sine rect rotation degrees. And these have to be, we need this in radians. So we have, what is this? It's rect rotation degrees. And we want to go in, we want to go from 360 to 2 pi. Yeah, I think it's like this. I think. And we use the rad rotation. He's way cooler. We like him better. Does sine with at, does like the built-ins not work here? I didn't know there were built-ins. What's the difference? Zig language reference. What's in here? So this sine trigonometric function on floating point number in radians. Use a dedicated hardware extraction when available. So why is there one in the standard library at all? What stud? Let's go to 0, 12 and look for sine. I just kind of assumed that since it was in the standard library, it didn't like, oh. Why? Okay, so I guess I should just use the built-in, right? Like, why depend on the standard library if I don't have to? I just didn't know it was there. That's kind of nice. Because I know that, like, when I was writing Rust without the standard library, it didn't have these functions. Because I think that it required, like, the math library from C. I think it required me to link against libm, which I don't really know what libm is, math, but, like, I don't really know what belongs in there. So it's interesting that it's a compiler built in. That's kind of nice. Because if I was decided that I didn't like to use the standard library, I still have it. Interesting. Okay. Why am I doing this again? I'm trying to find the corners so that I can sort them by height and figure out the like iteration functions. Right. Right. So bottom right is this. Top right is, can we draw this same thing? But I guess it's we do kind of have it here. But I didn't draw this like very aligned, which makes this harder. So let's try again. Let's try again. So let's just draw a box where we have corner here, 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 and here or something. So how did we get... So this is like a very slight angle here. Yeah. Which is... Right, so we have this triangle, and now we have this triangle is the one we're trying to look at now. So this is the same thing where... What angle am I looking at here? Because in the default case, we have these are my hypotenuse, my hypotenusae. How did I lose it? I fucking had it. This felt right. This felt right. But now I kind of feel like this is like the top right corner. So I feel like I've made a mistake somewhere. Or my brain is just fried. Why is it always so hard? It's always so hard. So in this case, the rotation is 0. So drawing these like diagonal lines is just confusing me. So in this case, rotation is 0. Then we rotate it a little bit. We have this angle here. Where does that get applied relative to the center again? Right, like just a very slight rotation. Boom, boom, boom. I guess that's not a slight rotation. We'll do the 45-degree rotation because I can draw that easily. But then I can... Yeah, it is something about like the outside box, right? It's this. So we have... Didn't I have it? I fucking had it. This. So given a small angle here, I'm assuming that this is the same. This is not the same angle as this, is it? Is like this? No. Probably not. Because this is off 45 degrees. Where is this angle going? I feel so stupid sometimes. Sometimes. Oh my god. Oh my god. So this is usually 45 degrees, and then I rotate by like a small amount, and this becomes 45 minus that small amount. This line does. I think this is wrong. This feels wrong to me. Right, because if I rotate... Yeah, this is something related to 45. So if I rotate 1 degree, this becomes 44. And then my triangle is cosine 44. Yeah, so I think that all of these should be stood math pi over 4 minus or plus. So in the default case, we're at negative 45. For this one, we're at positive 45. For this one, we're at... Yeah. Okay. So, yeah, the default case is that we are at 0 minus math pi over 4 for the bottom right. Yeah. So now, if we're at 0, this cosine, this becomes... I think that lines up. Let's just run this now. We'll return 1 point from this function. And we should see that the bottom right corner doesn't fucking move. So these have to actually be added to the initial locations as well. Yeah. Okay. So given some rectangle, this guy, if we say find rect corners, given this rect, we should be able to print this and see something. So const br is equal to this, and we'll say something, std debug print this point. Come on, baby. BR is an unused local constant. Why? Oh, because I didn't return it. Fine. I'll return from the function if you really want me to, Zig. Like, if you're going to be like that. Fine. You know? If that's what you need from me. Why? Okay. Expected rect found pointer. Okay, so I forgot to throw this guy like this. Math pi over 4 is ambiguous, so we have to say, yo, dog, could you be an F32, please? And we'll do that on math.pi, I guess, and then everything else. Which I guess kind of we can say like const pi F32 is equal to a float of std math pi, and then we don't need to do that. It's like fucking bullshit casts. We can just do like pi F32 here and here. Boom. Okay. So we ended up with 50, 30, which is good. So the cosine and sine didn't move our point. And let's make sure that the width and height are different sizes. So if we say that our width goes to 60, when we... Oh, interesting. I fucked up. What is the problem here? Right, here we should say rotation degrees equals 0. So if we do this right, nothing should move, but clearly something is moving, so we fucked up something. What did we fuck up? Right minus center, bottom minus center. We look at the x distance squared plus y distance squared, and we square root it so we get the corner distance. So that's... Okay, so we have our 30 and 20, and then we found this distance. So if we were to do a little bit of math here, we expect that to be 15 plus 10 squared square rooted. So we expect that to be 15 times 15 plus 10 times 10. We expect this to be... where's square root? This guy? 18.027. So we have corner, dist is this. Just to make sure that we're all good up to that point. Yep, chilling there. And so then let's see. So this we expect to be 0. And then we should be at, sorry, this is 0, which makes this part 0. And so we should be at negative pi over 4. Is that right? If we have 2 pi, that makes this pi, which makes this pi over 2, which makes this pi over 4. Yeah, so negative pi over 4 does make sense. So then we have corner dist. Okay, so we have what's cos 45 is 0.70. So we should be at 0.70 times, where is my value we're expecting? This. Times this. Did I do something wrong? Cos x is equal to adjacent over hypotenuse. So if we do h times cos x, we should get a. So doing all this, we should get back to just the fucking 15. Should we not? Have I just done something like blatantly stupid? Am I high? Did I just calculate the distances here wrong? Left to right is 30, top to bottom is 20. We got the right number for the corner distance. Am I fucking high? Okay. It's just a zig build and GDB. Breakpoint here. Run. So, BR rotation red. Negative 0.78. 3.14159 over 4. 0.785. Yeah, okay. Okay, nothing crazy there. So what is our like hello? Corner dist. Do I have like cosine? I do. So I can just run rotation red is 0.7. Yeah. Times corner dist. Is my width wrong? Top, bottom, left, right. Dude, I feel like I'm going mental. Surely I'm not this bad at math, right? Am I fucking high? Width is 30 times 30. Oh, this is width over 2. I'm a fucking idiot. God damn. Right? Minus. Dude, I'm gonna lose my mind. I'm gonna lose it. So we have 15 times 15 plus 10 times 10. Oopsies. 15 times 15 plus 10 times 10. Square root this guy. Great. That's the hypotenuse. Times 45 cosine. Hello. What? Surely I'm not this bad at math. Surely. Am I really just forgetting everything? This is 45. This is a 1, 1, root 2 triangle. So if I have some distance here, dude, what the fuck am I doing wrong? I'm certain, like, I have to question all of my assumptions. Because clearly I don't know how to do math. What is my center value here? Const, my CX is rect CX. Oh my god. Calculators are horrible for that correct precedence. Sure, but like, I just feel like I'm not doing anything crazy, right? But you're right. Like, we could look at Python and we could do 15 times 15 plus 10 times 10. 325. Square root that. Import math. Math, square root that. Right? That should be like, okay, we know that it's like, what are our 1, 1, root 2 triangle? Yeah, math, square root 2. Yeah, that all lines up. So this should be the length of the center of our rectangle to the corner. On a and then we should be able to just fucking do that times math cos 45 times math dot pi over 180. Like, what am I fucking missing? Like, why does this not just give me back 15? Like, this gives me the same number, right? Do I just not know how to do fucking Pythagoras? Why would it? I mean, maybe I'm just not doing math right. I feel like it should, but I might just be fucking stupid, right? But like, if I'm looking at this point, this is 0, 0, this is, I think that this distance is 15, and I think that this distance is 18 I think 45 is wrong angle for 1015. That's a really good point. Yeah, that's a really good point. Thank you. My fucking brain was just like on fire. Yeah, of course. Of fucking course. Thank you. So, first of all, I just didn't fill in the fucking angle here, which is... Oh, no, that's fine. Okay. Right, of course. Of course, of course, of course. That's what I was missing. I was like looking at like a square and thinking that this is always 45, but it's not. It is some like... Yeah, we're just going roundabout. Thank you. So this angle, do we even need it? What was I even trying to do? We were trying to figure out the... So this is what we're looking at. So the rotation is minus whatever the rotation already was. So we need to do like existing rot is equal to b a10 2. Yes. Yes. BR y distance from C, BR x distance from C. Thank you, because I was losing my shit. So it should be something like this. Does that give me 0? Okay, cool. Now we're fucking back. We're back, baby. Right edge stays at 60, like we fucking pushed it in. Woo! Dude, sometimes you're just fucking dumb. And by you, I mean me. Sometimes, gee, that's like so embarrassing. Super embarrassing. Just like the other day, how I just forgot about cross product for like 30 minutes. Blech. But I guess this is like what I get for live streaming myself coding. Sometimes it makes you look good, and sometimes it makes you look like shit, and it just comes with the territory. It's just how it has to go. Okay, so now if we rotate by 90 degrees, what we should see is if this is, I think that we should see it at, so if this is 60, 30, and this is 50, 30, we rotate around the center point, which is halfway between. So this is 45 and this is 40. So we should see it rotated so that we go, the X position should be 45 plus 10, so 55. And the Y position should be 45 plus 15, so 65. If I did the math in my head right. 35 and 55. I think I was just off a little bit. Let's think about that again. So this angle, 35 and 55. So is that right? So we have, this width is 20. So plus 20 is 55. No, that's 65. Where is this 35 and 55 coming from? Did I do the math in my head wrong? Let's see. 30 plus 60, 90 over 2, 45. Okay, that's right. And then we have 30 plus 50 over 2, or 80 over 2 is 40. So our center is 45, 40, right? And then our Y position is 40 plus 15, so 55. Oh, okay, that makes sense. And it should be 45 plus 10, which is 55. So, but we're probably just looking at the wrong corner, probably. This is probably just the wrong corner. Maybe we're rotating clockwise. Are we? Bottom right corner is this guy. And he's ending up at where? Large Y, small x. Oh, so he's ending up here. Oh, so it's just a clockwise rotation. Sure. Okay, clockwise rotation. Chilling. That's working the way we expect. Sorry, that took a while. So top right is the same thing, but our I guess we have to adjust the existing rotation. So it's just what? If we have a rectangle and we say this is 30, this is the negative of that value, and this is like 180 minus that value. Something like that. I guess we can just do the same thing over and over again if we want to get crazy, but okay. TR rotation rad is the negative BR rotation rad. And then the top left is Stub math pi minus the bottom left version is just this added to the top right plus the top plus pi, because you were doing a 180 flip. And then the top left is the negative flipped over. We need to flip it over. Oh, it's just the 180 of the other one. 180 of the other one. So it's math pi plus br rotation around. Okay, cool. Yeah, I think that's right. I guess we'll see pretty quick. So top right is the same, but we need to do top right for all of these. Top left is the same, and the top or the bottom left is bottom. Okay. And then this returns 4 points. And we return them all in a array. Order doesn't matter, I don't think. Okay. So what do we get now? 3.3, 5.5, 5.5, 5.5, 5.5, 2.5, 3.5, 2.5. I think that's right. Let's take out the rotation entirely. We'll go 0 degrees, and we should just see the original box. 6.5, 3.5, 3.3, 6.3, 3.3. Whoa, hold on. 6.5, right bottom, yep. 3.5, left bottom, yep. 3.3, left top, yep. And 6.3. Oh, right top, yeah, cool. Cool, okay, I think that's working. I think that is working. And so now, if we wanted to do the thing where we walk points, we have to find, first of all, these slopes, which should be pretty straightforward. We must have those from the rotation already. It's just like 90 plus rotation and the rotation. So, although maybe, does sorting by Y make sense? How many times do you think I can draw a rotated box? Because I just want to make sure that, like, so we, like, there's one scenario where we are in this orientation, right? And the first, like, we have long way going to the right and short way going to the left. And then there's the other case where, we'll draw it over here. The other case where we're just kind of rotated the other way. And so in both these scenarios, we have like one corner at the top, but the slopes are different. So maybe we can't just unconditionally sort them. Maybe we have to keep in mind which direction they're going in. Okay. So instead of returning 4 points, well, maybe we store them in like clockwise order or something, and then yeah, we have to know which points are connected to which points, I guess. So if we store them in like 1, 2, 3, 4, we just know that there's never drawing a line between 1 and 3, and that's okay. It's okay. Sure. So in that case, if we make sure that they're always stored in clockwise order, we just have to rotate this array until the first thing is the highest up. That's what we want. So we'll start with bottom right, bottom left, top right. That's already in clockwise order, which is great. And then we just find the element with the lowest Y position. Okay, yeah. So here we do something like std mem min given a point. Oh, I don't get to pass in a min function. Is there another version of this that does let me pass in a min function? Math min? No. Argmin? This looks kind of like it. So given a array of items, I give you a less than function and you give me the index of the smallest element. That's probably, like, we can look at this. So he's saying, given a list of I32s, and I am calling with ascending I32, I expect the minimum value to be 0, 1, 2, 3, which is what he's getting here. Yeah. Okay, cool. Stud sort argmin. Let's try it. Smallest element is stud sort argmin of point. Point, and we have our ret. I guess we don't. Yeah, we do need to put pointer there to coerce into a slice. Context is void, and less than is point less than. Point less than. And then here we say const point less than is equal to some struct, which has some function f, and f is this. So this is void. LHS is going to be a point. RHS is going to be a point. We return a boolean. We return LHS dot y is less than RHS dot y. We don't care about x resolution, right? If it doesn't matter because we're just going to keep them in clockwise order anyways. Okay, and then we can just do they have like a rotate? Surely they do. Yeah, std mem rotate. Nice. So in place, rotation of the values in an array becomes this if we rotate by 1. So it's rotating left, which is exactly what we want. So we should just be able to say ret or stud mem rotate by point, and we look at ret and smallest element. Okay. Side note. Oh, hold on. What is this complaining about? Expected type usize found and question mark usize. So we'll just assume that this exists. Okay. The side note is I was trying to understand why we pass in a type to all of these parameters the other day. And I was like struggling to understand because like if you take in an any type on this like rotate function, you could derive what t is from the input type. But they intentionally don't do that because if I understand what I was reading correctly, every time you instantiate, if you were to try to resolve the type, you might take in an array, or like when you take in a pointer to an array, instead of it coercing into the slice, like if I say like I have like some array of like 10 ints, right? If I take a pointer to this array, this turns into a pointer to 10 I32s, right? And then what ends up happening is if you were to call this function with type resolution, this would not automatically coerce into the runtime length representation of it. And so you would end up with a compiled function in your binary for every single array size that you call the function with. And there's just not a way around that, if I understand it correctly. So also easier for tooling when T is explicit. I mean, I'm not sure I 100% agree with that. This can happen in C++ as well. Yeah, with templates, yeah, it's the same shit. So anyways, that's why like I just would have assumed. It took me a long time to figure that one out. I was like staring at it for like hours, or not like hours, but like maybe like 20 minutes being like, why? I just don't get it. Why? But yeah, I'm pretty sure this is the reason that I found it on their bug tracker, and it makes sense. So if you're trying to decide when the fuck should I put T in here, I'm pretty sure that's the only reason why in this scenario. Pretty sure. Okay, so now we should have these guys in clockwise order with the smallest y value on top. So here we start with y of 3, then it's also 3, because we rotated by a number that lines them up. So let's just rotate by like 10 degrees or something. So we end up with 2.754, 2.754. Why are they the same height? Oh, there we go. There we go. 2.54, 5.45, 5.4. There's something suspicious in here where, like, why are my y values the same? I don't think that that's how it should line up. Like, what if I make like a really long rectangle? Yeah, I don't think there should be any two y values that are the same in here. But I am seeing that. Did I make a mistake? Bottom right. Top right, top left, bottom left. Right, I'm not crazy, right? I'm just a little. What is that from? I'm not crazy. I'm just Matchbox 20. Why is this in my head? All right. Okay, so if I rotate this box, is there a rotate feature in this thing? Selection, rotate. So let's say that I were to rotate this by 20 degrees. Right? All of these y values are different. Maybe we'll rotate it more. Just to really like amplify 45. Right? Pretty clearly these should all be different. So I must have fucked up something. As usual. 1.17, 1.17. Yeah, so my... And then are my x positions? My x positions should also be all different, and are they the same as well? Here I have x. Yeah. These are suspiciously the same. Suspiciously. So clearly it must be that this is not right. But I thought it was. So we have like boom, 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 boom. We have some center. And we have some rotation that we calculated to this guy, which is this angle. And then we say that is added to our overall rotation of the box. So far, so good. Oh, I think this is wrong. This should be... hold on. Let me just double check this. So this is our rectangular rotation rad. And I think that on this guy, it should be the rotation in radians minus this angle. Because the flipping over 0, negating it, is only true when rotation is 0. And then I think, but these guys being 180 offsets, I think stays true no matter the rotation of the box. I think. These are all different numbers now, which I like. That's what I like to see. And then let's just do the 0 rotation test again, just to make sure that the numbers stay with what we expect them to be. So it's 30, 90, 30, 50. 30, 30, 90, 30, 90, 50, 30, 50. Yeah, okay. Chillin'. Okay. Cool. Cool. So, all of that to say that we now have sorted y indices of this rectangle. Well, maybe not this rectangle, a rectangle. And so now we can just say this is 0, 1, 2, 3. And we just have let me think about this. If our rotation is really shallow, it looks like this. And I guess we just have 4 stages. And we just can keep track of that stage. I was trying to decide if you could like do some like absolute value shenanigans to not think about it. But I think that we do just have to probably mark the 4 stages. Maybe we don't, but that's what I'm gonna do. So expanding, we'll call it. Continuing, or okay, so we'll call this section expanding, this section contracting, and then middle. And I'll draw some ASCII diagrams for that later, but that's fine. Okay, so then we have to keep our stage in here. Our initial stage is expanding. And I guess maybe we'll have a little finished in here too. Because I don't know if we can use the width times height as our stop condition anymore. Okay. So, how do we handle this? I guess we will also have our 2 slopes. So we'll call this left slope, I guess. I don't know. And right slope. And in here, do we actually keep our pixels as, or corners as our 4 points in here? Is this what we keep instead of the rectangle? Then here we say const point corners is equal to find rect corners rect. Okay. We probably have to keep in track our current x start and our current x end. Yeah, that makes sense. And then maybe we'll store row as well. Okay. Then we're going to say like calc bounds, calc row bounds based off of self. Maybe that's fine for now. Fine for now. And then what? So here we have to initialize y to 0. Left slope is going to be okay. So you have corners 3 is the clockwise. We're working clockwise. This is the guy on the left. So we have the left slope is the x direction. Is my slope y over x or x over y? Y over x. So corners 3y minus corners 0y divided by this. Okay. And then right slope is everything in here gets replaced with a 1, I guess. Yup. Yup. So then this becomes left slope is equal to left slope, right slope is equal to right slope. And I guess we have... Maybe we don't need to calculate the stage. Maybe this just comes from the y value. That seems possible. So... what? We say if y... If our y value... Is this corner always the tallest? No. If it's... maybe. Because if we go like this, we've just kind of rotated. I think it is. When we're perfectly... Yeah, because if we started with perfectly axis aligned, they'd be the same. And if we tilted just a tiny bit to the right, then all of a sudden it's... Oh no, this one's taller than this one in that case. Okay. So we need to figure out something. Figure out something. So let's just say that we never turn around. These just go on forever. So that we don't have to think about anything for now. We just have our corners 0. So this position, his x position, plus right slope y equals mx x equals y over m. So self dot y over this. And I guess probably we should structure this as multiplication, but it's fine. We'll figure that out later. And then for start, we do the same thing, but we just subtract it. No, we add the left slope, sorry. Okay. Then we just return some struct that has like a min value and a max value. We return row bounds like this, and we just return, maybe we call it start and end. Doesn't fucking matter. And we will say, for now, if self.y is greater than 10, right, we're just for now, return null. Otherwise, I guess we need to take our x position, and we'll store this as current bounds. And I guess we'll say var ret is equal to this. Return ret. And then we can say ret calc row bounds. And just set current bounds to undefined. And this doesn't return the bounds. He just sets them internally. This is bad. I don't like this, by the way. I hate having a struct in like a semi-inconsistent state. I'm just too lazy to fix it right now. But I will fix that before we call this a day. Because, fuck that. You know? Okay. our x position goes like this. And so now we say, if our x position is greater than our current bounds max or end, and I guess this is probably greater than or equal to, we say self.y plus equals 1, and then we self calc row bounds again. Then we defer self.x plus equals 1. Then we say, oh, self.x equals 0 here. And then all we have to do is we just take our... no, his self.x equal to current bound start. Yes. And then our x is self.x. And our y is self.y. Is that really it? Might be. This guy doesn't like somewhere that he is a pointer, so this probably has to be dereferenced. It's fine, doesn't really matter. Calc row bounds. No function named calc row bounds here. Mr. Moo Game, thanks for the prime. Appreciate it. So maybe we have to say this is a pixel iter here. No field name rect, so we delete that. Try this again. Expected type F32 found usize. So that's okay. We can just do some little float from int or int from float. And maybe we'll put a little fix me on here and say round question mark. I'm not really sure. This guy has to say as usize for the type resolution to work. And we have some usize float bullshit, so as F32 float from int. As F32 float from int. I think I wish that the type resolution propagated a little farther. I think. Because I think that I like the verbosity of int from float and float from int. I think that makes sense. It should be painful a little bit to do those. But I don't know if I like the extra like syntax, like the extra brackets and function calls around like which type is my output. It feels like it's like a lot of noise. So I feel like it'd be nice if everything in here is a float 32, if this also resolved as a float 32, but I could also see the argument that you wouldn't want to accidentally truncate. If you expected this to be 64 and it like truncates and you didn't expect that, I don't know. Maybe. Okay, let's look at our thing. That's a good sign. That sure looks like it is a triangle of some form, which is good. Let's increase our Y max. We'll let it go 20 times. Okay, yeah, that definitely... Okay, does that feel like if we... What is our rotation at? 45 degrees? So if we make a square box instead of a long box, and we rotate by that much... That doesn't necessarily feel like these slopes are right, to be honest. Not sure. It's also weird that I feel like it's not changing. Can we just like maybe log what pixels coming out here? So when we start, our x is 0, which is wrong, by the way. Initial x and initial y should start at rect.top? No. Corners 0.y and corners 0x. That's where they should start. int from float. Okay. That feels a little, maybe that'll be clearer. Now, they don't start anywhere. And our next function just never fucking comes out with anything. So here our exit condition must be fucked. Yep. Yep. As you say, yeah, as, maybe we'll do a, we'll cast y here, as f32 float from int. Okay, let's see what that does. Okay, so now let's see if our x bounds are maybe moving appropriately here. So we start at x, y 25, and we move from 40 to 99. Then on the next row, something's wrong there too. Our calc row bounds, our start end is the corner 0.x plus y over slope. But the slope here should be relative to corners 0.y. Yes. So that it is 0 at first. Okay. Gross, but hopefully we're getting closer. Hopefully we are getting closer. Okay, so that's back to being a triangle again. And let's see if we like the bounds that it picked. So y26, x39. He immediately goes to x39, y27, and he moves a couple times. Then he goes to x39 again, y28, x38. Okay, so the question is do we believe that that's right? Sure, maybe. Let's look at our slopes now. Let's make sure that these are right. So I'm not really convinced. So we're seeing that the left slope and the right slope are very different, which is maybe a little surprising if we expected our rotation to be 45 degrees. What is our rect location? What the fuck? No symbol rect in current context. It's right here. P star rect. Okay, here we go. So we are expecting, with a 45 degree rotation, I would expect my two slopes to be the same. So it's very possible that maybe our corners are in the wrong spots. With a 45 degree rotation with a square box, which this is, right? Top to bottom, left to right. This is a square box with a 45 degree rotation. We would expect that our two x points, we should have two x's that are on top of each other and two y's that are aligned. Which we do here. We have x30, y30 and 50, and we have x40, y25 and 54. Wait. No, I don't think this is right. I do not think this is right. Why don't I think that's right? Because x is fixed in both. Oh, yeah. No, hold on. x40, y something something. x50, y30. No, something about this is wrong. Something about this is wrong. These points are not in the right place. I guess we should just do the math and actually check what we expect. So if we expect a 45 degree rotation on 30, 50, 30, 50. Halfway between 30 and 50 is 40. So this is 40, 40 in the center. So we would expect if this is 30, we would expect maybe something a little bit under 30, negative or like 28 dot dot dot, and 40. And then we would expect if this is 30 to 50, we would expect like 52 dot 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 and 40. So x40, y25, yep, x40, y54. That's looking okay. Then, if this is 40 here, we'd expect x40, y25, and x40, y54. So this feels right. It's this one. Sorry, what am I saying? The y ones aren't right. Y ones are not correct. So I must have just fucked this up again. Let's maybe breakpoint here. And before we do any adjustment, let's print ret. So what order did we store them in? Bottom right, bottom left, top right. Bottom right, bottom left, top right. So which ones are wrong? Top left, bottom left. Whoa, hold on. Bottom right is good. Bottom left, not good. Top left, good. Top right, not good. Okay. So it's... This is probably wrong. Yeah. So we were trying to go where we have... This is where we were looking at this. So we calculated this angle. And we're trying to say, what is this angle now, given that, right, we're at an angle like this, right? So we have, we find this angle, and we add it to this angle. Oops. I used the wrong... That's why. I used the wrong fucking argument there. Oopsies. Oopsies. Let's look at the picture again. Much better. That looks a lot more like a 45-degree rotated thing. Much better. And then let's try going back to, like, 25 degrees. And we should see the right side slopes bigger, left side slope bigger. Because it's a clockwise rotation. Looking good so far. I think that that's correct. Now all we have to do is figure out how to turn around. So surely it's like this function changes based off of some y thresholds. So this is like if let's think. So we need to think about, like we were saying before, depending on which way we are tilted, the first vertical point that we need to turn around at changes. It's like if we have gone, actually just check if we've gone past the min and max. Yeah. So it's something like if I guess we can maybe say that like there's like right y turnaround. We can calculate this once. And the left y turnaround. So y value at which we need to switch slopes. Yeah. Okay. That makes sense so far. But I guess if we have done that, if we are turning around here, we actually need to turn around relative to this point. Which means that we kind of need to store that or recalculate it. Yeah. Yep. That makes sense. Maybe we consider these as U sizes for now. Yeah, floats are fine. Floats are fine. And okay, so our right Y turnaround. This is just the value of corners 1Y. So we actually don't need to write these down. We already have these. We already have them. It's like if Y, so we'll say Y as a float is equal to float from int self Y. And if YF is greater than corners 1Y, we have backwards or second segment on the right edge. Right? That seems right. If it's greater than corners 3, then it's segment on the left edge. Yep. Okay. And if this is the case, we need to calculate this, but relative to corners 3Y instead of self Y. Okay. So we'll say const farthest left point. And then we do this, where we use the right slope, and we add this to the farthest left point. Based off of something. So let's think about this. So here we're saying, hey, we're moving left down to the corner. And then here we're saying from the corner. So this self Y becomes the left thing, as well as the left X position. Oh yeah, we don't need to calculate the fucking farthest X point. We already have it. It's the corner. It's the corner. We have the corner. Of course we don't need to calculate anything. So self.y minus this. Yeah. Oh, easy. Easy. Okay. Yeah. So we just do this. Var start is this, and if we're on this side, then we have to adjust the start just like we did the end. Which hold on. Am I high? I feel like we should be using... There's something wrong here. There's something wrong here. It's if we're above the top left, the left corner, we've gone past it, we need to start moving right. Oh wait, this is supposed to be, we're supposed to be fixing start here. If we're, because this is on the left side. Yeah, there we go. So we go right from the left edge. Yes. And then to adjust the end, we start going left from the right edge. So this is corners 1x plus y minus that corner's y over the left slope. Yeah. And then our exit condition is that y is greater than this, the bottom corner's y. That might work. And it exited. That's a really good sign. We got like a kind of rotated box. Also a really good sign. Let's expand this guy a little bit. Make him long. Okay. Okay. That might be working. It might be. Let's try a 90-degree rotation. Oops. Failed because integer part of floating point value out of bounds at 139. Current bounds end. Probably because there's a divide by 0 in here. Yeah, one of the slopes is infinite. Which makes sense. So we have to check the slope here. And if the slope is like super fucking big or super fucking small, we just have to clamp the y value or something. So this is probably yeah, we have slope of 0 here. And we're going from Jesus Christ, come on, we can do this. Like we're going from like here to here. We just have to clamp it yeah, we just clamp it. So minimum. Is there a clamp in this language already so that I don't have to lower and upper? Yep. Stood math clamp. I guess I know that the end is going to be on the other side. So we can say the minimum of self corners 1x end is equal to min self corners 1x and end. And the start is the maximum of the left corner. Still no good, eh? Can we maybe print the current bounds? What am I missing here? And negative infinity. Oh, so oh, yeah. Sure. So the end is going to be the min and the max of this, and we need to limit it to the bottom corners x as well. And then I think it's probably min here. Probably. Would an isinf help? I don't know, because I think that if it gets set to infinity, then I think we're like, the min should still work. We just have to make sure that we're not going like, it's just because like each side can iterate in 2 directions, I think. Okay. So we got close. At least we have like the rectangle, but we're missing the left and bottom edges. Did we fuck up? Like, let's go back to like a less degenerate case where we're rotated by 45 degrees. Oopsies. Maybe I should run the code first. All right, so we fucked something up here for sure. Let me just double check that if we comment out this... Oh. I'm not that stupid. Don't worry about it, guys. Don't worry about it. Shut the fuck up. Or maybe I should run my code? Alright, let's look at it again. Close again, but again, I just clearly fucked something up here. So here we are looking at the end. The end should not ever go past the rightmost corner, and it should always be above the bottommost corner. This isn't true. These should be checked here. Maybe. Yeah, maybe. Maybe I should run my code. Maybe one day I'll remember. There we go. Look at that. That's a fucking rotated rectangle. Now we're having a problem here. We're going a little too far past the bottom. But overall, that's okay. And then let's try going back to the 90-degree case and see if that fixes it. Maybe I should run my code. Fuck my life, man. Oh my god. End is negative infinity. End is negative infinity. So what's happening here? We have... How is end getting set to negative infinity? Because this slope should always be positive. I guess maybe this is ending up like at like -0 or something. Let's just GDB break here, run it, info, locals. Right slope is 0, left slope is infinity. So it's probably just that like the slope is 0 and there's like it's just turning out to be negative infinity instead of infinity, which is fucking annoying. So I guess you're right that we should probably just check if is inf, or we can also check if 0. We can also just check for if self right slope is equal to 0. And is equal to self corners 1.x, and we'll just say note min below does not quite work in some inf cases. I don't fucking know, man. Oh, it's nasty. Do we really have to do this? Can we avoid it? What if we just prevent the slopes from being that small? I want a more elegant solution. I really do. But maybe it's unavoidable. I guess you can make it elegant by splitting out a function. Which does... what? I guess we can just call clamp, actually. I wonder what happens if we just do all this and we say, the right side. Can we clamp this to something sane? Oh, fuck it. We'll just clamp it to the, stud mem clamp. No, stud math clamp. And we clamp the value, end, to the corners, the left corner is x, and the left corner is y. And that's not a perfect solution, but it's probably good enough to fix all of the degenerate cases, which are probably all the ones that actually matter. Probably. It's not perfect. Not perfect. Don't worry, we know. Where are... Hello? Where's my image viewer? Hello? Fuck. How's the coding? It's going okay. Slower than I would have hoped today, to be honest. But we have made some progress, at the very least. Some progress. Fuck, maybe I should run my code? Maybe we should run it? So this clamp just isn't working because there's some assertion failure that lower is less than upper because I'm an idiot. And this should be corners 1x on both of these. By the way, does Zig still accomplish generics through comp time? As far as I understand, yes. I don't think that they'll ever do anything different, but I could be wrong. Am I fucking high? Oops, yes, again. This should be start, not end. Run my code. Open the image. There it is. Okay, so there's our rotated by 45 degrees rectangle again, and then let's try the degenerate case at 90 degrees. Come on, baby, let's see it. Fucking finally. Fucking finally, we got there. There's a condition here that we're missing. And it's that when we call next, I think that we have to exit check our Y after we check our X's. Yeah. Yep. That'll probably fix it. Yep, there we go. There goes that bottom right pixel. And I think we fucking finally got there. So let's do like 25 degrees. Yep. 0 degrees. XGG open. Did I not say? Oh, I said 0. Yeah, okay. Okay, wait, yeah. Yeah, okay. I think that's working. I think it's working. Pretty sick. I wish I had got through that faster. I was really planning on accomplishing a lot more than that today. And I guess I was just trying to, like, I guess I used to work with this stuff a lot more, right? I think the trig was fresher in my head. Like the last job I worked at, I was doing a lot of like 3D stuff, and you're doing this all the time and doing triangles, like raycasting and stuff. And I also worked with like pan tilt zoom cameras, so you would like click on a point on the screen and you would like do motor control stuff, and it was just all so fresh. And maybe I'm either misremembering how good I was at it back then, or I've gotten a lot worse, or probably both. So a little frustrating that like something as simple as this was so much effort, but we got there. We got there. And sometimes that's just the way it's got to be. So good enough, though. Good enough. So thanks for watching, guys. If you like what you saw, we're streaming most days at around 2 o'clock Pacific time for around 2 hours. So right now it's 4 o'clock Pacific time, so anywhere between 2 hours ago and now. There's a GitHub link and a YouTube link in the Twitch description, so if you want to check out like the code for whatever we're working on or look at previous projects, that's all there. Previous projects kind of just trend into whatever the fuck I feel like, which trends towards lower level, do-it-yourself, start from scratch. Right now we're working on this QR decoder, so for those of you who jumped in late, we are trying to work towards getting this style of annotations on a QR code that's aligned like this. So that's why we're working on rotated boxes, because we wanted to be able to like shoot along this axis and color check the stuff in the rotated box. So right now we're drawing in this rotated box, but the way that we've implemented it is by iterating pixels. And so if we're iterating pixels and we just get coordinates, we can choose to look at those pixels instead of coloring them, right? Same shit. Yeah. So I think that's it for now. Let's figure out who to raid, and I'll catch you guys on the next one.